So I'm Michael McDonagh. I'm representing Steelike. Steelike is a commercial supplier of UHPC, ultra-high-performance concrete. And really over the course of Steelike's business, we have innovated a number of placement techniques, really mixing and placement techniques for ultra-high-performance concrete, which I want to talk about today. So first, I'm going to do a very brief introduction of UHPC. Then I'm going to talk about UHPC connection construction, how it's typically done, our innovative methods, and then do the same for overlay construction. And I'll just give a very brief introduction to some new UHPC placement equipment that Steelike has manufactured, and then I'll wrap it up. Now, today is this session is the third session on UHPC. But nobody has gone back to the basics as far as what is UHPC yet. So I'm going to take the opportunity. I'm sure there's somebody in here who cannot tell me what the typical rapid chloride test result is for a UHPC. Am I right? I see some people smiling. All right, so I'm going to keep it brief. So UHPC is a fiber reinforced cementitious composite, typically a very low water to cement ratio. We're looking at less than 0.25. And the values in yellow or orange would be typical values for conventional concretes used in bridge construction. 22,000 psi is a typical 28-day strength for UHPC. There's significant tensile strength, which depends on the quantity of fiber. Strain hardening, I think we've seen a number of discussions about that today, so don't need to go into that very far. And then in terms of durability for a rapid chloride test, typically less than 250 coulombs is considered a requirement for a UHPC class material versus 1,000 is considered a really good value for conventional concrete. So I want to also briefly touch on Steelike UHPC because these innovative methods that we've developed, we've only used them with Steelike UHPC. So there is a chance that maybe there's something unique about Steelike that allows it to happen, or maybe just others haven't tried it yet. So just very briefly, Steelike UHPC, it of course meets the Federal Highways definitions and pretty much every agency out there. We're pre-qualified in a number of states. And we have premium properties, and I'll explain that in a second. Steelike is also relatively unique by being all white. And then we have flexible mixing options and unique placement techniques, which is what I'm going to go into in detail today. Steelike traces its history back to 1991. But Steelike UHPC, as we know it today, really came together around 2010, and 2016 was kind of our breakout year with a significant project with the U.S. military, and our growth has continued since then. So my comment about premium properties, on this table here on the right, I have lower and upper bound values established by the Federal Highways or New York State, who's been an early adopter, and several properties on the left. Compressive strength, we've had some lab studies that take our material as high as 27 KSI. Shrinkage, we're certainly on the low end of the range. I think it's fair to say we are Steelike is a low shrinkage UHPC. We're extremely low on chloride permeability, and for freeze thaw, our material actually gets stronger as you do the testing, whereas the limit is that it can't degrade beyond 96 or 98% from baseline. And scaling, we don't experience any scaling. I mentioned it's white, so these are just some photos of some Steelike overlays. Whiteness can create a cooler rotary surface. It's also very practical for architectural applications. All right, with that out of the way, I want to go into first traditional construction methods for UHPC so that then you can better understand the innovations that Steelike is bringing to the industry. So for connections, and these images are showing connections between precast deck panels. Typically, if we start on the top left, you have specialized stationary mixers that are often rented from a UHPC supplier. And because they're stationary, then the material is discharged into concrete buggies. So top right, sorry. I'm probably getting my left and rights mixed up, so I'm going to bring up my laser pointer. So we started here with a mixer, now we're here with the buggies. The buggies transport the material, they dump it into the connections, and they shuttle back and forth until the connections are full. Then the connections are placed, then top forms are placed on the connections. since bridge decks are never level in both directions. So this prevents the material from running away on the low side, but it also has a secondary effect of trapping air that may be getting displaced or escaping out of the UHPC. So most agencies then say, okay, if you're going to top form, well, since you need to top form, we need to set those forms high, so air that gets trapped as it works its way up is above the deck cross-section. And so then when you remove the forms, the bottom left is what you see, and then that has to be grinded off. So with that as sort of the baseline of traditional UHPC construction practices, now I'm going to introduce the innovative methods that Steelike has developed. The first method, and this is key to several other follow-on benefits, is using standard ready-mix trucks for mixing UHPC. Number one, you eliminate the need to transport specialty mixers around the country to job sites. These trucks are just locally available, and they have very large batch sizes. So we can mix up to 7 cubic yards in a single batch, versus the typical mixer used for connection jobs maxes out around 0.6 cubic yards, and they have smaller versions from there. This is something Steelike has been doing since 2015. We've batched well over 1,500 batches in ready-mix trucks, never had a failed batch, and we've done it in all conditions, hot, cold, wet, dry, you name it. So it's a reliable method that we employ as our default whenever we can. And we've even managed to keep batches alive when disruptions to projects occur. The slide here says an hour and a half or more. We've actually gone as much as 2.5 hours. And we might be able to go further, we just never have the need. So that kind of eliminates any fear of, oh, we have such a large batch, what if it goes bad? You know, there's a lot of money in those 7 yards. Well, that's never been a concern for us. We have the tools at our disposal to prevent that. So a follow-on benefit by using a ready-mix truck to mix, that truck is inherently mobile. So now we can eliminate buggies. Buggies can be rather inefficient. They require buggy drivers. You need multiple of those. They generate a lot of waste. So when the site conditions permit, we are discharging directly from the truck into the connections, which saves a lot of time and reduces material waste, as I mentioned. So the photo on the right, here we're discharging, as I said, directly into a connection. In this case, we have the luxury of a temporary work trestle alongside the bridge, because a lot of times you can't drive heavy equipment on bridge deck panels that are not connected yet. If that scenario is the case, well, then the photo on the left shows a great alternative. Typically, you're going to have a crane on site anyway if you're setting girders or panels that you are then connecting with UHPC. So the ready-mix truck can drive right up to the reach of the crane, and the discharge is high enough that it can discharge right into a concrete bucket. Concrete bucket can carry, I think, typically about 2 yards of UHPC, and then that can discharge right into the connections as well. It's nearly as efficient as directly discharging from a ready-mix truck. And I have a video here taken from the viewpoint of one of our employees standing on the crow's nest of the truck. Let's play a little bit until it kind of gets moving. I didn't air it up there, I do. No, it's not going to. Let's see if I could advance it though. So of course they're kind of just getting their groove on, so to speak. But you see they're starting to make more progress, and you notice there's 5 guys in the video. Only like 1 or 2 of them are actually doing anything. So, it's a testament to the efficiency of this method, as opposed to having 2, 3, 4 buggies, a driver for each buggy, plus the guys at the connection making sure all goes in. think you get the idea, so I'm going to advance. All right, so the third innovation, which in this case is not tied to using a ready-mix truck, is the ability to eliminate grinding. You know, I talked about, because bridge decks aren't flat, you need to top form, and you top form, you need to overfill to keep that trapped air layer out of your deck cross-section. So Steelike, we've learned over the course of many projects that our material can be placed without top forms. We believe this is a property somewhat unique to Steelike UHPC, which is that it stiffens up relatively quickly once it becomes static. So the advantage to that is you can fill up your joint, and depending on the cross slope, maybe it'll start to overflow a little bit, but generally it'll stop before it becomes a problem. If it even flows outside the joint at all. So this has allowed us and contractors working with our material to just eliminate top forms altogether. And it's kind of a beautiful way of doing it. And as Bill, our president, likes to say, it's WYSIWYG. What you see is what you get. You no longer have things hidden beneath the top forms. So with no top forms, there's no trapped air, no overfill. So you're limiting the overfill material, you're limiting the need to fabricate top forms. And probably best of all, from an environmental standpoint, you're not grinding and creating those plumes of dust, sending those into the environment. Now, sometimes if slopes are too steep, if the temperature is too cold, we still need top forms. But we've learned that we can still set those forms flush, wait for the material to stiffen up a little bit, just because it takes a little bit longer if it's cold out, for instance. And then we can still remove the forms and do any touch-ups if we need to. And then once again, no overfill, no grinding. So we found that has also been an efficient process that has saved contractors.
This is a 7-degree pitch.
Well, I guess
that's longitudinal, and then it's got a 2-degree pitch. As you can see, there's no top forming. The boards are just there because the state didn't think it was going to work. So we're not even touching those 2x4s.
The recent job, as Bill's voice in the video said, 7% pitch was longitudinal, so transverse to the link slab, and then it had about a 2% cross slope. And as you saw, no top forms and no need for top forms. All right, so now I'm going to go through the same process with UHPC overlays, because that's really these are the two main applications of UHPC that are getting the most use currently. So once again, if we start at the top left, you'll see typically specialized stationary mixers. Now, because the demand for material, or the material need for an overlay is typically more for a joint project, you need bigger mixers. So in this case, the supplier provided 2 mixers that I believe can mix about 1.3 cubic yards per batch. But once again, these are stationary. They had to be transported across the country. They need generators to power them that the contractor has to rent. You can kind of see the edge of a generator here on the left, and there's one behind here for the second mixer. Since the mixers are stationary, you need buggies to transport the material. And here you can see a photo of just a whole load of UHPC being dumped all at once from a buggy, which does create a potential risk of trapping air because you're dumping it onto a very roughened surface that's been prepared with hydrodemolition. Next, commonly UHPC overlays are cured using plastic sheeting. It's usually a combination of curing compound plus plastic sheeting. And once the curing is done, they're typically grooved and grinded. But as you can see in this photo, a lot of times plastic sheeting leaves marks in your overlay surface that are even deeper than what can be grinded out, because this is the final grinded and grooved surface. So it's kind of a shame when that happens, because here you have this extremely durable material that could last 100 years. Well, now you have these defects, even if they're just aesthetic, that are going to be there for the next 100 years. So in terms of Steelike innovations, of course, we're going to go back to ready-mix trucks again. As I said, that's our go-to method for mixing whenever possible, whenever it makes sense. We've done that for multiple overlay projects on the Newport Pell Bridge, in Illinois, as you can see in these two photos. And I mentioned in the title here also off-site mixing. We can do that for both connections or overlays. I mention it here because it was done for the Newport Pell Bridge. The UHPC was actually mixed in the ready-mix trucks about a mile or a mile and a half away, and then driven onto the bridge for discharge. So that adds additional flexibility if you have a very congested construction site. You can move the whole mixing operation to somewhere else. Once again, mobile ready-mix truck means you can eliminate the buggies. And for overlays, this works exceptionally well because I have a hard time thinking of a situation where you can't just drive the ready-mix truck onto the deck to discharge it. The only case might be if you're doing a really deep overlay where you're going below the rebar mat. Yeah, so once again, by eliminating buggies, you're reducing labor, reducing equipment, you are reducing the waste generated by those buggies and accelerating everything, and potentially also...
All right, here's the last 3 or 4 feet.
There we go. The video is still playing now? Okay, good. So, you're also greatly reducing, by using this method, so you see the truck just drives right up to the screed and just lays down a ribbon of UHPC. By doing that, as opposed to buggies that are dumping large piles, you're also greatly reducing the risk of trapping air under the placed UHPC. And now I've lost my presenter screen here. I got it. So you can see the chute kind of waving back and forth, placing the UHPC. And once again here, take a look at the number of workers that are there. There's one on each end of the screed, making sure it's advancing. And 2 or 3 guys with rakes. So it's a very efficient way of placing UHPC overlays. All right, and then finally, elimination of plastic sheeting. Steelike has been doing this since 2020, so for 2 years now, and we are curing overlays with just curing compound. We found that that it works, and it eliminates all the risks of using plastic sheeting. As I mentioned before, having deep impressions that are stuck there for potentially the next 100 years. There's also potential safety concerns, because if you're doing a project with staged traffic, maybe unexpected wind gusts could come up and blow the sheeting into traffic, potentially. So if you just get rid of the sheeting, all those risks are eliminated. Now, I've seen recently that another project has started doing this with another material with no plastic sheeting. So I think that's a great thing, and I'm glad they're following our lead. So I'm running out of time here. I have some slides here about some new placement equipment, but I'm going to leave that to the presentation. We have another presentation, not next, but the following one, where I can really go into detail on that, and I'll save that for then. And yeah, so I just have some quick conclusions, really just reviewing everything that I presented. That the new methods that Steelike has introduced is mixing in ready-mix trucks, and then taking advantage of the mobility and the large batch sizes that provides to really make UHPC placement more efficient. And then for connections, eliminating diamond grinding. We like to call it the no-form system, with kind of a pun on the word no, because there's no forms, but you also know what's going on. And then for overlays, again, taking advantage of the ready-mix trucks, the mobility, the large batch sizes to eliminate buggies, and then finally eliminating plastic sheeting.